The Greatest Show on Earth, by Richard Dawkins. Introduction. Imagine for a moment that you are a history teacher. You love your subject. You're passionate about the ancient world, about the poetry of Ovid, the speeches of Cicero, the grand strategies of Julius Caesar. Your goal is simple: to share this passion, to bring the Roman Empire to life for your students. But there's a problem. Every single day, you're forced to waste your time. Your lessons are interrupted by a loud, well-funded group of people who insist that the Romans never existed. They claim the entire Roman Empire is a hoax. They argue that languages like Spanish, French, and Italian just appeared out of nowhere, with no connection to Latin. Instead of teaching the Punic Wars, you find yourself in a constant, draining battle, defending the very idea that Rome was real. It would be laughable if it weren't so exhausting. This is the exact position that many science teachers, and indeed many scientists, find themselves in today. They want to explain the central, guiding principle of all biology, the theory of evolution, but they are constantly forced to defend it against people who deny it as a fact. This is where the brilliant biologist Richard Dawkins steps in. With his landmark book, The Greatest Show on Earth, he decided to set the record straight, once and for all. He realized he had written books explaining how evolution works, but he had never laid out, in one single place, the overwhelming mountain of evidence that proves evolution happened. This book is that case. It has sold millions of copies and has become the definitive guide for anyone who wants to understand the evidence for themselves. Dawkins doesn't write this as a scientist speaking to other scientists. He writes it as a passionate teacher, a clear-thinking guide, walking you through the greatest story ever told. And today, I'm going to share that story with you. My promise is that by the end of our time together, you won't just understand the evidence for evolution. You will feel its power. You will learn to see the story of life written in your own hands, in the birds outside your window, and in the grand sweep of Earth's history. You will gain the clarity to see past the noise and confusion, and appreciate, perhaps for the first time, the sheer grandeur of this view of life. So, let's begin our journey. Let's step into the role of a detective, arriving at the scene of a crime that happened millions of years ago, and piece together the clues that life has left behind. Book summary. Our journey begins with a simple, powerful question that lies at the heart of so much confusion. When people want to dismiss evolution, they often say, "Well, it's only a theory." Richard Dawkins invites us to think about what that word, theory, really means. In everyday conversation, a theory is just a hunch, a guess. I have a theory about why the car won't start, but in science, a theory is something entirely different. A scientific theory is a grand, overarching explanation for a huge collection of facts. It's been tested, confirmed, and supported by every piece of evidence we've found. The idea that the Earth revolves around the Sun is the heliocentric theory. The idea that germs cause disease is the germ theory. And the idea that all living things are descended from a common ancestor is the theory of evolution. These aren't just hunches. They are the bedrock of our understanding of the universe. To say evolution is only a theory is like saying gravity is only a theory. It's a profound misunderstanding. Evolution is a fact. It is as solid a fact as the existence of the Roman Empire, and the evidence is just as clear, if you know where to look. So, where do we start looking? Dawkins suggests we don't begin with dusty fossils or complex genetics. We start somewhere much more familiar. We start with your dog. Think about the incredible variety of dogs in the world. A tiny, trembling Chihuahua and a giant, gentle Great Dane. A sleek, lightning-fast Greyhound and a stocky, stubborn Bulldog. It seems impossible that they could all be the same species. But they are. And more than that, we know for a fact that they all descended from a single ancestor, the wolf. How did we get from a wild wolf to a pampered Pekingese in just a few thousand years? The answer is artificial selection. Human beings acted as the selecting agent. For generations, we chose the wolves that were a little tamer, a little more friendly. We bred them together. Then, from their offspring, we chose the ones with the traits we liked, perhaps a shorter snout, a curlier tail, or a particular coat color. We repeated this process, generation after generation. We became sculptors. But instead of sculpting clay, we were sculpting the very genes of these animals. Dawkins calls this the primrose path to understanding evolution, because it's so easy and pleasant to follow. Look at what we've done with farm animals. We've bred cows that produce far more milk than any calf would ever need, and chickens that lay an egg almost every day. Or consider the humble wild cabbage, a weedy little plant you might not even notice. In just a few centuries of careful selection, we have sculpted that one plant into an astonishing array of different vegetables. Broccoli, cauliflower, kale, Brussels sprouts, and of course, the cabbage you find in a grocery store, they are all descendants of that same wild ancestor. They are all the same species, just shaped by human hands for different purposes. This is the first great clue in our detective story. If human selection can produce such dramatic change in just a few centuries, what could a different kind of selection achieve over millions, or even billions, of years? This brings us to the heart of Darwin's great idea. He realized that you don't need a conscious, intelligent selector like a human farmer or a dog breeder. Nature itself can be the selector. Dawkins walks us through a beautiful series of stepping stones to help us see how. Think of flowers. We breed roses to be more beautiful, to have more vibrant colors and intoxicating scents. But who was the first rose breeder? Long before humans ever walked the earth, insects were doing the selecting. A flower that was slightly brighter, or had a slightly sweeter scent, attracted more bees. Those bees, in turn, carried its pollen to other flowers, meaning the brighter, sweeter flower had more offspring. Generation after generation, the eyes of insects sculpted the flowers, just as our eyes did later. The flower, in turn, was sculpting the insects, rewarding the ones that were best at finding nectar and spreading pollen. This is still selection by an outside agent, an insect, but it's not conscious. The bee isn't trying to create a more beautiful flower. It's just following its instincts. Now, let's take another step. Think of a peacock. The peacock's magnificent tail is a brilliant, shimmering spectacle of color. But it's also heavy, cumbersome, and makes the bird a walking target for predators. From the point of view of pure survival, it's a terrible idea. So why does it exist? Because for generations, peahens have preferred to mate with the males who had the most extravagant, most dazzling tails. The tail is a signal of health and strength. A male who can survive despite carrying around such a handicap must be a truly superior individual. So, the peahens acted as the selectors. They weren't sculpting for survival, they were sculpting for beauty. Darwin called this sexual selection. In all these cases, the dog breeder, the bee, the peahen, an outside agent is making a choice. But Darwin's genius was to realize that no agent is needed at all. Survival itself is the choice. Imagine a herd of gazelles being chased by a cheetah. The gazelles aren't all identical. Some, by pure chance, are slightly faster than others. Which ones are most likely to survive the chase? The faster ones. And which ones are most likely to live long enough to have offspring? The faster ones. And what will they pass on to their offspring? The genes that helped make them fast. Now, think about the cheetahs. Some are slightly faster than others too. Which cheetahs are most likely to catch a meal and avoid starvation? The faster ones. They too will pass on their genes for speed. Over millions of years, This process creates an arms race. The gazelles get faster because the cheetahs are getting faster. The cheetahs get faster because the gazelles are getting faster. As the Red Queen said to Alice in Through the Looking Glass, it takes all the running you can do to keep in the same place. This is natural selection. It is simple. It is automatic. And it is powerful enough to explain the entire diversity of life on Earth. It is the engine of evolution. But for this engine to have had enough time to do its work, the world has to be incredibly old. Our detective, piecing together the story of life, must first establish the timeline. Just how old is our planet? History deniers often claim the Earth is only a few thousand years old. This, as Dawkins shows, is not just a little bit wrong, it's wrong on a scale that is difficult to comprehend. He says it's like believing the distance from New York to Los Angeles is about the length of a football field. So how do we know the true age of the Earth? We have clocks. Not clocks that tick in seconds, but clocks that tick in millions of years. One of the simplest is the tree ring clock. Every year, a tree adds a new ring of growth. In good years, the ring is wide. In bad years, it's narrow. By matching the unique patterns of wide and narrow rings from living trees to dead wood, and then to even older, petrified wood, scientists have created a continuous calendar stretching back over 11,000 years. This alone disproves the young Earth idea. But for the truly deep time, we need a different kind of clock, the radioactive clock. Certain elements in rocks are unstable. They decay over time into other elements at a perfectly predictable rate. Think of it like an hourglass. When a volcanic rock first forms and cools, it's like turning the hourglass over. It contains a certain amount of an unstable element, like potassium-40, and none of its decay product, argon-40. Over time, the potassium slowly turns into argon. The half-life of potassium-40, the time it takes for half of it to decay, is 1.26 billion years. By measuring the ratio of potassium to argon in a rock sample today, geologists can calculate with incredible accuracy how long ago that rock formed. There isn't just one radioactive clock, there are many, each with a different half-life, perfect for measuring different spans of time. Uranium-238 has a half-life of 4.5 billion years. Carbon-14 has a half-life of 5,730 years, perfect for dating more recent things like ancient human artifacts. And here's the beautiful part: all these different clocks agree. They all point to the same conclusion. The Earth is not a few thousand years old. It is about 4.6 billion years old. That is an almost unimaginable stretch of time. It's more than enough time for the slow, gradual engine of natural selection to have produced the magnificent diversity of life we see today. With the timeline established, our detective can now turn to the clues left at the scene: the fossils. Creationists love to talk about gaps in the fossil record. They demand to see the missing links. As Dawkins cleverly points out, this is like a defense lawyer in a murder trial arguing that because there's no security camera footage of the hallway between the pantry and the library, his client, who was filmed loading a gun in the pantry, must be innocent. And if the prosecution then finds footage of him in the hallway, the lawyer triumphantly declares, "Aha! Now there are two gaps in the evidence? Before he entered the hallway and after he left it." The fossil record is a bonus. The case for evolution would be rock solid even if we had never found a single fossil. But the fossils we have found tell an incredible, consistent story. The most powerful thing about the fossil record is not what we find, but what we don't find. If evolution were false, we might expect to find fossils jumbled up in any old order. We might find a rabbit in the Precambrian rocks, from a time before mammals were supposed to exist. The biologist J.B.S. Haldane famously said that's what it would take to disprove evolution. But we have never, not once, found a single fossil that is authentically out of place in the timeline. And what about the missing links? They aren't missing. We have found them. Thousands of them. Dawkins takes us on a tour of some of the most spectacular transitional fossils ever discovered. Let's look at one of the greatest transitions in the history of life, the move from water to land. For hundreds of millions of years, our ancestors were fish. To live on land, they needed to solve a host of problems: how to breathe air, how to support their weight without the buoyancy of water, how to move around. For a long time, there was a gap in the fossil record between the lobe-finned fishes, with their fleshy, limb-like fins, and the first true amphibians with legs and feet. So, paleontologists did what detectives do. They made a prediction. They said, if we are looking for a creature that is half fish, half amphibian, we should look in rocks of a specific age, about 375 million years old, and in a specific type of environment, ancient river deltas. A team of scientists led by Neil Shubin did exactly that. They went to the Canadian Arctic, to a region with rocks of precisely the right age and type. And after years of searching, they found it. They found Tiktaalik. Tiktaalik is the perfect missing link. It had the scales, fins, and gills of a fish. But it also had the flattened skull and mobile neck of an amphibian. And most importantly, inside its fleshy, fin-like appendages, it had the beginnings of the bones that would become the arm, wrist, and hand of every land vertebrate that followed, including you. It had a humerus, a radius, and an ulna. It was a fish that could do a push-up. It was the perfect bridge between the water and the land. The story doesn't end there. We see the same pattern in another great transition: the return of land mammals to the sea. The ancestors of whales were four-legged, wolf-like land animals. The fossil record now shows us a beautiful step-by-step sequence of their journey back to the water. We have fossils like Pachycetus, a creature that was still mostly land-based. Then Amballocetus, the walking whale, which had legs but could also swim powerfully. Then Rhodocetus, whose nostrils had begun their journey from the tip of the snout to the top of the head to become a blowhole, and whose back legs were becoming tiny and useless. And we see this same story in our own ancestry. The taunt, "Where's the missing link between apes and humans?" is now completely obsolete. The fossils are no longer missing. We have Australopithecus, like the famous Lucy, a creature with a chimpanzee-sized brain that walked fully upright on two legs, 3 million years ago. We have Homo habilis, the handyman, with a larger brain, who was the first to make stone tools. We have Homo erectus, taller and with an even bigger brain, the first of our ancestors to leave Africa and spread across the world. The fossil record shows a beautiful, gradual transition from ape-like ancestors to modern humans. The problem isn't a lack of links, it's that we have so many links that it's often hard for paleontologists to agree on where one species ends and the next begins. This, Dawkins argues, is exactly what we should expect if evolution is a gradual process. The arguments over names are a testament to how complete the record has become. But fossils are only one line of evidence. Our detective has more clues to examine. He turns his attention to the map of the world today. Why are certain animals found in certain places and not others? Why, for example, do we find kangaroos, koalas, and wombats, all marsupials, mammals that raise their young in a pouch, almost exclusively in Australia? And why, in the rest of the world, are the dominant mammals placentals, like us, who nourish their young with a placenta? Why are there no native land mammals in New Zealand, except for bats that could fly there? Why are all the 37 species of lemur on the island of Madagascar, and nowhere else? The story of Noah's Ark offers no explanation. It would require us to believe that all the marsupials boarded the Ark, disembarked, and then made a beeline for Australia, without a single one stopping along the way. It would require the lemurs to do the same for Madagascar. It makes no sense. But evolution makes perfect sense of it. Dawkins explains this with the beautiful idea of the arc of the continents. We now know that the continents are not fixed. They drift across the Earth's surface on tectonic plates. Hundreds of millions of years ago, all the continents were joined together in one supercontinent. Australia broke away from the other continents long ago, when the dominant mammals were marsupials. It became a giant, isolated arc, and the marsupials on board evolved to fill all the available ecological niches, producing marsupial equivalents of wolves, cats, and moles, without competition from placental mammals. South America was also an island continent for millions of years, which is why it has its own unique fauna of armadillos, sloths, and New World monkeys. Madagascar broke away from Africa, and the primitive primates that were stranded there evolved into the incredible diversity of lemurs we see today, free from the competition of the monkeys and apes that evolved later on the African mainland. The distribution of life on Earth is a perfect map of its evolutionary history. As Darwin himself realized from studying the finches and tortoises of the Galapagos Islands, the life on any island most closely resembles that of the nearest mainland. It's as if one species had been taken and modified for different ends. Now, our detective turns to perhaps the most intimate and powerful evidence of all. He looks at the bodies of living creatures themselves. He discovers that history is written all over us. Your own body is a living museum of evolutionary relics. When you get cold or frightened, you get goosebumps. This is the useless, leftover action of tiny muscles at the base of your body hairs. For our furry ancestors, these muscles would have made their coat fluff up, providing better insulation or making them look bigger and more intimidating. We've lost the fur, but we've kept the muscles. They are a vestige of our past. Whales, which we know return to the sea, still have the tiny, useless remnants of hip bones and leg bones buried deep inside their bodies, a clear signature of their four-legged ancestors. Some snakes, like pythons, have tiny vestigial hind limbs, little spurs that are the last remnants of the legs they no longer need. But the evidence goes deeper than useless leftovers. Evolution isn't like a perfect engineer, designing things from scratch. It's more like a tinkerer, modifying what's already there. And this tinkering process leads to some truly bizarre and inefficient designs that no intelligent creator would ever have come up with. This is the argument from unintelligent design, and it is one of the most powerful proofs of evolution. Dawkins' prime example is the recurrent laryngeal nerve in mammals. This nerve controls the larynx, or voice box. In a mammal, it branches off the vagus nerve in the chest, near the heart, and then travels all the way up the neck to the larynx. In a human, this is a strange, but not absurd, detour of a few inches. But now consider a giraffe. The nerve still branches off in the chest, near the heart. It then travels all the way down the giraffe's magnificent neck, makes a U-turn around a major artery, and then travels all the way back up the neck to the larynx. It is a detour of 15 feet. This makes absolutely no sense from a design point of view. A sensible designer would have simply run the nerve directly from the brain to the larynx, a journey of a few inches. So why this absurd detour? The answer, once again, is history. Our distant fish ancestors had no neck. The nerve followed a direct route from the brain to one of the gills, looping neatly under a blood vessel on its way. As evolution progressed and the neck lengthened, the nerve got hooked on the wrong side of that blood vessel. Natural selection couldn't just go back to the drawing board and start over. It could only work with what was there, so it simply stretched the nerve, millimeter by millimeter, over millions of generations, resulting in the ridiculous detour we see today. Our own bodies are full of such historical quirks. The drainage hole for our sinuses is at the top, which makes perfect sense for a four-legged animal with a horizontal head, but is terrible for a two-legged animal with a vertical one. Our backbone is a mess of compromises, ill-suited for an upright posture, which is why so many of us suffer from back pain. History is written all over us, not in elegant monuments, but in the clumsy, patched up, and wonderfully imperfect way our bodies are put together. Finally, our detective reaches for his most modern and powerful tool, molecular genetics. If all life is descended from a common ancestor, we should be able to see this relationship at the deepest level of all, in our DNA. And that is exactly what we find. The most astounding fact revealed by modern biology is that the genetic code is universal. Every living thing on this planet, from a bacterium to a blue whale, from a redwood tree to you, uses the exact same dictionary to translate the language of genes into the language of proteins. The letters may spell out different words, but the alphabet and the dictionary are the same. This is stunning evidence that all life is one big family. We can now compare the exact sequence of DNA letters between any two species. When we do this, we get a precise measure of how closely related they are. The DNA of humans and chimpanzees is more than 98% identical. The DNA of humans and monkeys is less similar. The DNA of humans and mice is less similar still. And the DNA of humans and fish is even less similar. By comparing the DNA of thousands of species, we can build a family tree of all life. And here is the killer blow to any idea of separate creation. We don't just have to use one gene to build this tree. We can use thousands of different genes. And every single time, they all tell the same story. They all point to the same family tree. If a designer had been at work, picking and choosing the best genes for each creature, we would expect to see a jumble. A gene from a worm might show up in a monkey, if it did a good job. A gene from a fungus might be borrowed for a flower. But that's not what we see. What we see is a perfect, nested hierarchy of relationships, a tree of cousinship that unites all living things. The molecular evidence doesn't just confirm the family tree that biologists had already worked out from anatomy and fossils, it makes the case so overwhelmingly powerful that to deny it is to deny the most solid and well-supported conclusions of modern science. The evidence is all around us, and inside us. The story of evolution is the story of our planet, and it is our own story. As Dawkins concludes, echoing Darwin's own beautiful final words in On the Origin of Species, there is grandeur in this view of life. From a simple beginning, over billions of years, a process of staggering simplicity, the non-random survival of random variation, has given rise to a spectacle of endless forms, most beautiful and most wonderful. The greatest show on earth is not a circus or a play. It is the story of life itself, and you are a part of it. Commentary. So, what do we take away from this incredible journey through the greatest show on earth? For me, the most powerful lesson is not just that evolution is a fact, but that seeing the world through an evolutionary lens transforms it from a static collection of objects into a dynamic, unfolding story. It gives everything a history, a context, and a sense of profound connection. Richard Dawkins' great gift is his ability to communicate not just the what of science, but the wow. He doesn't just present the evidence, he invites you to share in the wonder of it. The story of the recurrent laryngeal nerve isn't just a quirky anatomical fact, it's a breathtaking piece of detective work that reveals a 400-million-year-old history. The similarity between your hand and a bat's wing isn't a coincidence, it's a testament to a shared ancestor and the incredible adaptability of life. In a world where misinformation can spread in an instant, this book is more than just a science lesson. It's a lesson in how to think. It teaches us to value evidence, to appreciate logic, and to have the courage to follow the facts wherever they lead, even if they challenge our preconceived notions. The grandeur that Darwin spoke of is the realization that we are not separate from nature, we are a product of it. We are connected, through an unbroken chain of ancestors, to every living thing on this planet. We are cousins to the chimpanzee, more distant cousins to the kangaroo, and more distant cousins still to the oak tree and the mushroom. This isn't a demeaning or a bleak idea. It is, I think, the most beautiful and humbling idea that science has ever given us. It replaces the need for miracles with something far more wonderful, a natural process, unfolding over immense spans of time, that has the power to generate the astonishing complexity and beauty of the living world. So, how can you start to see this for yourself? Here are 3 simple things you can do, starting today. First, the next time you see a dog, any dog, whether it's a poodle or a pit bull, take a moment to really look at it. Try to see the wolf that still lives inside it. Notice the way it cocks its head to listen, the way it interacts with other dogs, the instinct to guard its family. You are watching thousands of years of evolution and selection, both natural and artificial, playing out right in front of you. Second, look at your own hand. Spread your fingers. Notice the 5 digits, the opposable thumb. Now, picture a bat's wing, with those same 5 fingers stretched into long, delicate spars. Picture a whale's flipper, with those same 5 fingers hidden inside. You are looking at 3 different solutions to 3 different problems, all built from the same ancestral toolkit. It's history, written in bone. And third, if you can, go to a good natural history museum. Don't just rush to the giant dinosaur skeletons. Find the Hall of Human Origins. Look at the fossil skulls. Start with Australopithecus, small and ape-like, and then move through time to Homo habilis and Homo erectus. As you look at the progression, the expanding brain case, the shrinking jaw, you are looking at your own family album. You are tracing the steps of your own deep ancestry. That was a summary of The Greatest Show on Earth by Richard Dawkins. We've journeyed through the core of his argument today, but I'll be honest with you, a summary is like looking at a postcard of the Grand Canyon. It can show you the shape and color, but it can never capture the sheer scale, the awe, the feeling of standing on the edge and looking down into deep time. The real magic happens when you read the book for yourself. This summary is designed to help you decide if this book is worth your time. If the story of Tiktaalik, or the giraffe's nerve, or the continental arcs has sparked your curiosity, then I urge you to grab a copy. Reading it isn't just about learning facts, it's an experience that can fundamentally change the way you see the world and your place in it. A link to the book is in the description. Also, if you found this summary valuable and it sparked a new way of thinking for you, please show your support by hitting that like button and subscribing to the channel. That way, you won't miss our next journey into another life-changing book. Let's keep learning and growing together.